To you by the Detroit Edison Foundation, created and funded by Detroit Edison to promote the economic, social, educational, and cultural well-being of the communities it serves, and by viewers like you.
The sandhill crane winters as far away as Mexico and migrates all the way to Siberia. Think about that the next time you complain about commuting. Discover more fascinating facts about cranes of the gray wind next time on Nature.
Tomorrow night at 8 on WTVS.
How can a planet covered by cool oceans be hot enough inside to melt the hardest rock? Join us in a search for the heat within, next time on The Miracle Planet.
Tomorrow night at 8 on WTVS.
Let me tell you a story I know, all about trains and where they go, all about trains and what they do, all about trains.
Last time on All About Trains, we talked about laying track. But trains don't just go in a straight line. That's why this time on All About Trains, we're going to talk about laying switches. Good morning, Herman.
Good morning, Chuck.
This is Mr. Herman Wilson, the Vice President of Operations for the Arkansas and Louisiana-Missouri Railroad. I've asked Mr. Wilson to give us an explanation of what makes a switch work and how they turn it, or as we refer to it, bending iron.
Chuck, a switch works by moving one of the two movable points into another position. When the point is lined in this position for the main track, the train naturally follows the main track. With the switch lever, you move this point into an unusable position, put that one into use, and the train would follow into the side track.
Now, what's the difference between what I've heard referred to as a turnout and a switch? Aren't they?
Well, the turnout is a complete piece of track work where one track turns out from another. The switch is only this first part that comprises the two movable points, but they're used interchangeable. The frog is where the two rails from one track, one from the other cross over, and it's made in a V shape so that the wheels and flanged so that the wheels can go on either track. And that just separates the two tracks. In order to ensure that the wheels don't go down the wrong way, you have a guardrail on each side, and that holds the wheels over against the outside rail to be sure that the wheel on the inside follows the proper flange wheel on the frog. It's basically all there is to a turnout: the switch, the guardrail, and the frog.
Herman, when I've gone to the hobby shop to pick up switches, one of the things that the person in the shop has mentioned to me before is a stock rail, but I'm not really quite sure just what that is.
Chuck, the stock rail is this rail that turns out to the side track part of a switch, and stock or bent just before you get to the switch point, about 8 inches, in order to assure that this switch point fits up tight against the rail. The stock or bend in it gets its name from the stock or bend in a shotgun stock.
That's basically the operation of a switch. Let's take all of this now and see if we can apply it to our layouts. With me today are two guests, Dave Beidel and Paul Harwell. You'll remember Dave from our last episode on laying track. This time, Dave's going to show us the fundamentals of laying a switch. He'll even show us how to hand lay a switch. Later on in the episode, Paul Harwell is going to show us how to operate a switch, or as we refer to it, bending iron. First, I'd like to ask Dave, what's the difference between what we call a switch and a turnout?
Chuck, there's no difference really between a switch and a turnout. Modelers have historically called a track switch a turnout in order to differentiate between that, the one that switches tracks, which is a train on a track, and an electrical switch that they use in their track wiring. The parts of the switch in the model are the same as in the prototype. You have a stock rail on each side, you have a frog, you have the wing rails, you have the closure rails, and the points that actually do the moving. I've prepared a surface here that simulates the roadbed, and we're going to take this commercial switch, and I'm going to show you how to lay this switch as if it were on your layout. First thing you do is you lay it down and make sure the end of your rails here are going to line up with your other track. There are two different basic ways to lay these kind of turnouts, these general kind of turnouts. Some of them come with little holes in the center of the ties, and they're made for putting track nails in. Others come with little holes out by the edge of the tie that are made for putting a little track spike in. You spike it down. I usually start in the center. Then I do the two ends. Making sure, once again, that everything lines up. And when I'm happy with my alignment, I go ahead and put spikes in all the rest of the little holes that they have for the spikes.
You'd go ahead and run a car or something through to make sure, and that would be all you'd need?
No, you'd use a track gauge. The NMRA standards gauge is used to check your track, your straight track, your curved track, and your switches. You need a gauge to check to make sure the rails are not too spread or too narrow, or that make sure your wheels are going to roll through a switch. First, we're going to check our point area. We're going to rock the track gauge in and make sure that it's not too close. Your point area you want pretty close to maximum width on your gauge. It'll give you a better rolling quality.
Does that mean that it should be snug a little bit then, or a little loose?
No, you want it close to as loose as possible without falling in between the rails. We're going to check all the way down, and we're going to check the diverging route also. Make sure nothing is too tight or too loose. And we're going to flip the gauge over, and we're going to use the little flangeway nubs. We're going to check our guardrails and our frog area to make sure we're not going to strike anything when we're rolling through. We can't have a wheel rolling down through the frog, and because the track is too wide a gauge, falling over, or because it's too narrow, striking the frog and taking the diverging route. Then you'd have a derailment. Once you're satisfied everything is in place, go ahead and roll your car through it. Run your engines through it.
Dave, that's all well and good, but I've got a couple of areas on my layout where a commercial switch will not fit. Now, what do I do about that?
Let me show you what we can do about that, Chuck. We'll take this commercial turnout, and you can take it and cut it with a razor saw or an X-Acto knife or something like that between every other tie on opposite sides of the rail. Now, what that does, in effect, is make this switch into a piece of flex track. And then you can carefully bend it to whatever shape you need without having to actually build a whole turnout.
Does it follow it all the way through then?
It flows right on through. You have to use your spikes to hold it over a little bit, but you can cut it and make it into a flex track turnout.
Then I just come back
or
with
as the commercial curvable turnouts are nowadays.
Well, then what do I do? Just come back with the gauge then like the others and make sure that it's...
Just check it the same way you'd do anything. I do not recommend cutting it between the ties around the point area or around the frog area, because those are critical areas. Now, the other way you can do it is you can hand lay your own rails and build your own switch.
Well, that's pretty difficult, though.
It's time-consuming. It's not really that hard. There's two basic ways that I use to lay out a turnout. One way is to use a printed template, which has a specific frog angle. This is a number 5. You can get templates that are available number 4, number 6, and they show exactly where the ties go, exactly where the rail is going to go. Now, that to me is kind of the hard way. I would rather take and build a switch to fit a specific location, and however it lays is however it lays. If it works out to be about a number 10, it works out to be about a number 10. The way I draw the basic area is by using 2 old pieces of flex track. I take one and line it up with the straight track, or it could be, they could both be curved in opposite directions or the same direction. But I lay the first one down, and I bend the other one to the angle I need to line it up. And I take a pencil and I just draw along the edges of the ties. This will show me where my ties are supposed to end up. We've got the outline of a switch. Then I take wooden ties. These are switch ties. They're similar to what we used for regular track, but they're longer. And I glue them down. And when the glue dries, you can come along and trim them up with the edge of the lines you drew. And your little switch block of your ties is all set up. Now what I've done is I've prepared a rail base already with ties, ballast, and drew my lines first and everything in order to make it a little easier for us tonight. Before we get into that, though, before we actually lay any rail, I want to talk a little bit about some tools that we use.
Okay.
First, we have a pair of needle-nose pliers. Everybody has their own favorite pair of needle-nose pliers. Those are used for driving spikes. The weight, the way they fit your hand, it all depends on how you feel with that pair to see if that's your favorite pair or not. And your favorite pair is what you want to drive the spike with. Then we have another pair of pliers I use. These I use to cut the rail and to bend the rail if I'm making a large bend. We have assorted files that we use to trim down the rail, to smooth up the ends. We have a small straight edge, make sure the track through a straight port of it turn out as straight. We have a couple different types of gauges. We have the NMRA standards gauge, and then we have a couple 3-point gauges to hold the track in line while we spike it down. This is an abrasive block to use for cleaning the tops of the rails when you're done. I have a little container of spikes and, of course, ties.
Okay.
First thing you want to do is you want to set up your straight track or one of your stock rails. It doesn't have to be straight. If I've got a straight switch, I start with that. And you set it down, line it up where you want it to go, and down in this area you want to come down a tie past where the throw bar mechanism will be. This is where the throw bar goes. And you want to put a little mark there. We're going to file away the base of the rail in this area for about 2 inches up. File it down to a nice notch all the way up against here, but just the base. We don't want to file the head away. This is going to make a little receptacle for our point to fit into. Now, rather than physically do it to this, I've already got one prepared with this little notch filed in it to save a little time. I'm going to take and spike this rail in place. The critical part of this rail is right down here where the point notches in. You want to put a pair of spikes as close as you can to where the point will fit without going up into the area where the actual point will fit to stabilize your rail there. Then I usually come down the other end and kind of line it up by eye and put another pair of spikes in somewhere down at this end. Then you can use your straight edge if you want to line it up, make sure it's nice and straight. If you got a longer straight edge, it'll work a little better, and that's nice and straight. That'll do pretty good. Then we'll go back, and except for the area between where our notch is and about a dozen ties out, we're going to spike about every 4th tie all the way down.
Okay.
Now, we don't want to do it in here because the points have to fit in there, and we don't want any spikes on that side. We can use them on this side, on the outside, but not on the inside. Now we want to make the rail that goes on the diverging route, the other stock rail. I have one prepared here with the notch already cut out in it. And I'm going to come down at the end where the points go. I use my NMRA gauge and check to make sure I've got the rail within gauge before I spike it. And we'll check periodically as we go along to make sure that we maintain our gauge.
Wouldn't a 3-point gauge work just as well?
No, the 3-point gauge is not accurate. It's not a machined accuracy. We're going to use it to hold this rail in place right now while we put the other spikes in, but it is not accurate enough to do any measuring from. the NMRA gauge, you always come through and check after you're done with the NMRA gauge to make sure you got it the way you want it. At the point end, we want the gauge to be a little bit on the wide side. We want to get it about as wide as the gauge will allow before it drops in. It's a little different from what we'll use down at the frog end. The frog end we want right at minimum gauge. Now, this is our curved rail. We want to bend it on out so it forms a nice, smooth flowing curve here, and stab a couple spikes in here. Okay. Now what we want to do is we want to make a little frog rail. Okay, the frog is actually an angle that diverges. That's where the two pieces of rail would cross. So what we want to do is we want to take a piece of rail and file off one side of it to make half that angle, roughly.
Okay.
The sharper the curve you make, the less that you have to file to get the angle. Come along with your 3-point gauge to hold it in rough position. And just put a couple spikes in. That's good for there. Now we want to do the same thing for the other part. Okay, here's where we need the NMRA gauge. Both rails have to be gauged just perfectly from each side. If they're held apart, too far apart, we can slide them down. That's why we didn't force these spikes down yet.
Okay.
We can slide them to make them fit.
Now, are you just going to leave it sit, or can I come and attach something back here to hold these in place afterwards?
You can come along and solder that in.
But does it matter?
It's really a little better if you do.
Okay.
It'll hold it in place. You don't have to worry about it slipping.
Okay.
Electrically, it'll make a better continuity.
Ah, okay.
And it can fill your frog up to make it look more realistic. But you don't have to.
Okay. I just
You don't
wanted
have to.
I was curious about that.
If somebody's afraid of soldering, they really don't want to be building a switch anyway, because we've got some soldering to do down here on the points.
Okay.
This is just a matter of filling it a little bit with solder. Next, we want to we've got our frog and our stock rails. We need something to connect the two. We're going to build the point rail and the closure rail all in the same piece. What we're going to do is just come up here about 3 to 4 ties past the point of the frog. We're going to make a little bend in this rail like that can help catch a wheel and bring it in to roll in case it's reaching, close to the point of derailing. Just kind of, instead of hitting this thing, it'll grab it and pull it in. And we're going to hold this rail out here. We're going to slide our track gauge along until we contact that rail.
Okay.
We're going to mark that point. Okay? Keep an eye on the mark you made. We're going to bend it. Right at that point, we're going to put a little bend in it, and there's the makings of our point rail. It's going to connect right through there. Now, what we need to do is, using the gauge again, check to make sure we've got the point where it touches. Come down here to the very end of your notch and draw a little mark. That's where we're going to cut it. We're just going to snip through it and take a file and dress up the end so it's nice and smooth and not rough. The first thing you want to do is you want to take another file and remove the head of the rail only. This is the part where, the very top of the head is the part where the wheels roll on. But the head comes down a little ways, and it's the side of the head that you want to remove on the inside of that point. When I say the inside, the side that's towards the inside of the switch.
Okay.
Okay, we want to file it away about 1 inch. What this does is this gives us a smooth flow from the stock rail onto the points. Without doing this, you'd have a bump every time you hit, every time you came through the points.
Possible derailment then?
Sure. Bounce the wheels right on out.
I never thought of that.
Okay, we've done that. On the inside, we want to come up about roughly 2 inches, and we want to file away the whole side of the rail flat. We want to taper it down to a fine point. That's what I call them points, because they taper down to a fine point. So this is what it'll look like when you're done.
Oh,
Okay?
it sure is.
We filed the head away over here, and on this side, it's just filed down to a point. And you take your piece and lay it in using your gauge and a couple spikes. Bring it down to where you're just going to touch it, and spike your rail in place. Now we're going to spike this all the way from the throat, which is where we made this bend. This is called the throat of the frog. We're going to spike it about 4 to 6 ties down towards the end of the point. You want every tie spike to hold it in place. If we spike down to here, it's going to be hard to bend this, as opposed to spiking back to here. It bends nice and easily and smoothly. And that's exactly what throwing a switch is bending the iron. As the term, the rail was made out of iron, and they had to bend the iron to move the switch, to move through the switch. Let me review what we've done then, Chuck. We've determined where our ties and everything are going to go by either the template or by the center line, or the lines we drew, the outside lines. We've laid our ties, and then here I stained them and ballasted. Come along and put the 2 stock rails in. Put half of a frog in, which becomes the stock rail for the next one in this case. Came in, put the other half of the frog in, laid one of the point rails, laid the other point rail, the guard rails, and the tie bar, and now we can throw the switch.
Are there other ways that I can throw this switch without having to use this manual type throw?
Ask Paul.
Okay, Paul, how do you throw a switch? Well, Chuck, there are 2 basic ways of throwing a switch, or as they say, bending the iron. There are the manual or hand throw type switch machines here, or the automatic or electrical switch machines, which we have examples of both here. I've gone ahead and mounted a switch on the layout surface. Now this is all plastic, right? Yes, sir. We have this mounted on a plexiglass surface, so you can see it from the underside also. The simple procedure in a hand throw is, it is thrown by hand, of course. This is the lever that actuates the throwing. This is a vertical one. You just flip it over. There's also another style which mounts in the exact same way. Rather than flipping it over vertically like this, it is a horizontal thing. You just twist it from side to side. As you can see, the throw bar mechanism moves as we turn this around. Okay, those are basically the hand throws. What I'd like to talk about now, Chuck, is the common off-the-shelf type electric switch machine that comes mounted on the switch itself. This is the standard 9-inch sectional track piece for a right-hand switch. This comes from Atlas, Tyco, all the different manufacturers make this. This has an electric motor here. This is actually mounted on the side of the ties of the switch. It is connected to the throw bar here, thus moving the points there. When you reverse the polarity of the switch machine, it throws it the other way. Now I'd like to show the differences in the electric switch machines, Chuck.
Okay.
This is the old standby. It's been around for a good while. It's very powerful. It's called the twin coil type. It basically has 2 electromagnets in it and a carbon throw rod inside, as you can see here. When the electromagnet is charged, it throws it one way, which is already thrown. You reverse the polarity on the electricity and it throws it the other way. Okay? That's the machine's function, is throwing like this. Now there are several ways to connect this to the throw bar on the switch itself. Okay? One way is to connect this to a linkage, such as we have here. This is the linkage itself. We'll just pop it right in there. This has a little arm that extends off of this. All right. This connecting rod or connecting bar connects to the switch machine. Now, this switch machine can be mounted underneath the layout on a block of wood, about 2 inches by 3 inches, underneath like so, or it can be mounted on top of the layout surface beside the switch. If you mount it underneath, it is hidden and you don't have to camouflage it in any form. There are also another type that has just come into vogue here recently, which mounts the switch machine itself vertically underneath the switch. This is on the market now. It's called a Rix rack. Before, we had used this type of linkage in between the switch machine and the linkage. Okay, now with this vertical type switching, vertical mount on this switch, we're going to use this type. This runs up through here and connects to our linkage like so. We're going to crimp it a little bit with the needle nose pliers so it won't come off, like so. Now we're ready to mount the Rix racks to the underside of the layout surface. Okay, we've already drilled a hole in the middle of the rails. There's a hole in the throw bar there also. We're going to put this up through the layout board. We already have the holes drilled here to mount the Rix racks itself. I'm going to turn this over, go ahead and run the screws through it. Like so. Okay, now our Rix racks is mounted. As before, the switch machine was mounted horizontal to the underside of the layout surface. This one is mounted vertically or at a 90-degree angle to the layout surface. This goes up through the middle of the rails, and when the electric switch machine is activated, throwing this mechanism, it throws this back and forth, thus throwing the points of the switch, aka bending the iron.
This week, we've showed you how to take care of switches if you want to put some in. We've talked about prototype, we've talked about commercial, and we've talked about hand-laying switches.
In our next 3 episodes on All About Trains, we'll look at scenery.